You were all set to witness the image they claimed would be the definitive view of 3IATLAS. That side-profile photograph captured at the moment interstellar visitors glided past Mars. However, what we received was merely a blur. A blur that conveniently emerged after weeks of anticipation and following a comprehensive array of observatories being aimed at it. Hubble, Webb, HIRIS, MAVEN, Psyche, and numerous amateur telescopes scattered globally. Along with this blur came unsettling news that should alarm anyone. 23,689 radio signals detected by the Meerkat radio telescope. A grand total of 23,689 pings within the range of 900 to 1,070 MHz frequency range that, in our terminology, intersects with devices typical of cell phones. All this was recorded from a staggering distance of 280 million miles from the object, according to observers. But don't panic. Operators stated that these signals were not spatially aligned with Atlas, suggesting they were likely human interference. Yet if they were nothing more than noise, why specify exactly 23,689 events? Why not simply claim that no detection was made? This sets the stage for the narrative we're about to unfold concerning what is shown, what is left out, and what the data might actually indicate. The core issue: sharp image versus official image. HIRI, the camera on board the Mars reconnaissance orbiter, came within 20 million miles of Atlas and was expected to provide us with a side view boasting a resolution of approximately 19 meters per pixel, up to 3 times more refined than Hubble. This was our opportunity to examine the object closely and finally classify it, be it a comet, a rock, or something that defies traditional classification. What was ultimately released, however, was a muddled image, blurred by spacecraft vibrations, resembling a softened version of reality rather than showcasing what this technology is capable of delivering. In the meantime, amateur astronomers employing basic telescopes shared stacked images and time-lapse videos that, for many, revealed more visual insights than the official photograph did. Why is this significant? Because the quality of the image dictates what we can interpret: jet orientation, signs of fragmentation, plume color, nucleus size, and the presence of surrounding structures. When the official image fails to meet the standards of independent records, the inevitable question arises: what was filtered out, and why? The 23,689 signals present what was acknowledged versus what remained unaddressed. Let's be straightforward. Detecting 23,689 signals in a techno-signature search is no small feat. Although reviewers might later determine none of these signals were aligned with Atlas, the mere act of recording them carries implications. First, it establishes a documentary trail. Should something consistent emerge later, that information can be revisited. Second, the phrase they used, likely human interference, does not close off potential interpretations. It's a cautious phrasing. It doesn't convey, "we detected nothing." Rather, it suggests, "we detected something but couldn't connect it to the object." That subtlety is significant. Furthermore, alternating hydroxyl signatures appeared and disappeared in brief intervals. Hydroxyl can signify interactions with water or can result from material expulsion mechanisms. This intermittent behavior spurs hypotheses regarding cyclical, whether natural or artificial, processes that merit deeper exploration. These anomalies are why Avi Lowe feels apprehensive, and why you should feel the same. Astrophysicist Avi Lowe compiled a list of Atlas's characteristics that, when considered collectively, paint an unsettling portrait inconsistent with the ordinary comet classification. Let's summarize them clearly. A trajectory that aligns with the plane of the planets, which is statistically improbable for a random interstellar traveler. Columnated jets that point both toward and away from the central star of our solar system, forming long, narrow structures never before documented. At this level in natural comets, combination of mass and velocity that is extraordinarily rare. Millions of times more massive than Oumuamua and thousands of times heavier than the typical comet, yet still exhibiting significant speed. Precise passes by Mars, Venus, and Jupiter, suggesting the object is following a predetermined path. A composition with nickel proportions reminiscent of industrial alloys. An exceptionally low percentage of water, anomalous for standard comets, mid-extreme, light polarization surpassing anything previously observed for this type of object. An apparent origin tracing back to the direction of the famous WOW signal, a statistically improbable coincidence. Changes in brightness and color near perihelion, becoming brighter and more bluish compared to the star at the center of our solar system, interpreted by some as activation of an engine. An inconsistent energy requirement, where the jets would necessitate a collector, area far exceeding that of the nucleus 11. No fragmentation observed. Despite jets so powerful, they should obliterate any natural. Body 12. Jets remaining stable during the object's rotation, indicating directed control rather than chaotic emission. Debate can arise over each anomaly in isolation, yet together, they construct a mosaic that doesn't conform to the known catalogue of natural comets. This is the crucial point. When the physics doesn't reconcile, the issue needs clarification. To simplify the matter without diminishing its gravity, the jets reported around Atlas extend for millions of miles. That alone constitutes an anomaly. For a traditional comet to generate jets of such magnitude, the sublimation rate would have to be monumental, and that demands energy supplied by the light of the star at the center of our solar system. However, when we compute the energy required to sublimate carbon dioxide at the observed scale, we arrive at a staggering requirement. Atlas would need to absorb energy equivalent to 3 x 1018 joules during perihelion. To secure that amount, it would necessitate an area greater than 600 square miles, corresponding to a body roughly 14 meters wide, about 4 times larger than current estimates. If the substance were water instead of carbon dioxide, the necessary diameter would leap to over 30 meters. The conclusion: there isn't enough surface area on the object to account for the jet strength. Thus, either the jets stem from factors beyond natural sublimation or an undisclosed energy source exists. Columnated jets, stability across millions of miles, excess nickel, and intermittent hydroxyl emissions. Are these of extreme natural origins or technology? Plausible hypotheses that demand investigation. Exist: directed thrusters, controlled ejection systems, multiple probes accompanying the nucleus 2-4, industrial-like surface structures, artificial. Electromagnetic emissions. Dr. Avi Lowe asserts that this isn't a case of mind abduction or fantasy. It's straightforward. When the natural explanations fail, one must explore the artificial possibilities. That's the essence of the scientific method. The official briefing. A lot of words, but few elaborations. The AY's press conference seemed rehearsed to dodge the term anomaly. The language was meticulously chosen to communicate normality without addressing any of Lowe's 12 critical points. It's not a conspiracy, it's scientific politics. The aim is to provide the minimum necessary information to prevent sensational headlines while steering clear of the uncertainties that truly matter. The issue: when institutions maintain silence, the community seeks to fill the void. Sometimes with theoretical constructs, other times with imagination. Amateur astronomers delivered to the public what major agencies failed to provide: clear, stable, unfiltered images. Many of these demonstrate narrow jets, unusual colors, rapid brightness fluctuations, and lateral structures absent from the official image. This resulted in a peculiar phenomenon. The public began trusting backyard telescopes over official photographs. And that's a healthy development. Science thrives on community, and critique is integral to the process. The upcoming weeks are pivotal. We require more precise spectra, robust mass loss measurements, reinvigorated targeted searches for radio signals, and multiband imaging capable of revealing various objects or structures surrounding it. If any of these elements come to light, we could reach a critical turning point. And even if they don't, we'll still glean valuable insights. Both outcomes provide learning opportunities. Atlas arrived as a question, and it continues to be one. Amid the high-rise blur, the 23,689 signals, the remarkably lengthy jets, the atypical composition, in the selective silence of institutions. we're left with far more uncertainties than answers. And that's okay. It epitomizes science in its purest essence. If Atlas proves to be a natural phenomenon, we'll uncover new realms of interstellar chemistry. If it's technological, we may just realize that we're not alone. In either case, we emerge victorious. What is vital now is resisting simplistic explanations and persistently posing the right questions. What are your thoughts on the data? Do you genuinely believe the 23,689 signals were merely human interference? Was the high-rise image genuinely as poor as it appeared? Do the jets align with your understanding? Comment and share this video. The discussion must carry on. And don't forget to subscribe to stay updated. The story of Atlas is far from over.